the clock, radar's electronic eyes watch the skies and report what they see to SAGE, defense system of the United States Air Force. Here is a SAGE center on 24-hour alert. At its heart is a computer developed by a research team from MIT and IBM working with the Air Force. The SAGE computer speeds the information for decisions by man in our missile age. Every scheduled flight across American frontiers is recorded ahead of time on IBM punch cards, then fed into the SAGE computer. Now the computer can draw a picture of what is supposed to be in the sky at any moment. It continually compares this expected picture with the real picture as seen by radar. If a flying object does not belong, it appears...
Hello. Welcome to episode 4, Ground Stop Anomalies. In this episode, we're going to use... 60-second recap. January 10th, 2022, there was a pretty unusual multi-region ground stop by the FAA because of the North Korean missile test that happened at the same time. They grounded air traffic, stopped departures, told aircraft that were flying around that they had to land. And it was a pretty chaotic 10 or 15 minutes. During that 10 or 15 minutes... Oh, hi.
Hi.
Oh, okay. You going to bed?
I have hiccups.
Oh, okay. Good night, everybody.
Good night.
Love you. See you in the morning. Bye, my little feral child. Good night. During that 10 or 15 minutes, there was... They rejected takeoff by a United Airlines passenger jet at LAX. They were taking off, and a small airplane crossed the runway when it shouldn't have. And so I just got interested in this, and I thought it'd be interesting to see if during the ground stop period, if there were any other anomalies, like other rejected takeoffs, maybe go-arounds. So I'm writing a program to analyze the data. So that's a little replay of what happened, not in real time. So I'm writing code to find any other weird anomalies like that. And so far we've written the code. We've got the aircraft history data that we're processing in GeoJSON format. We have a really simple heuristic for trying to detect a rejected takeoff, which is an aircraft that is on the ground and has accelerated, has reached a threshold of, I think, 50 knots, and then decelerates. So we did that. It found a lot of false positives, mostly because a lot of aircraft were reporting they're on the ground when they're not. So we basically found every aircraft that was doing that. And so last episode, what we tried to do is add in some additional data, the locations of every runway. And we're filtering out any aircraft that are not close to a runway. What's our runway max distance meters? About 10,000 feet converted to meters. And we didn't quite get that working last time, so that's what I'm going to try to do this time. And I forgot to show my desktop this whole time again. It's okay. This is what the rejected takeoff looked like at LAX.
Wingspan 5, verify hold short, runway 25 right stop.
16, rejection on the runway.
So that's what it looks like. So we have one definite positive example of this. So actually, why don't we Oh, this is written in Rust, by the way. I'm using VS Code. I'm not a great Rust programmer. That's just how it is. So we have this detect rejected takeoff function, which takes the basically takes a vector of runway information. We have this runway struct, airport ident, and position of each runway. We have a big vector of those. Aircraft state is position, altitude, ground speed, and timestamp. So detect rejected takeoff takes one aircraft's history and is looking for rejected takeoff. So I had a few ideas. So one thing is, let's find that one example. So the United Airlines aircraft hex ID A081CA. Let's take a look at our data here. Okay. So this is in GeoJSON format. It's a feature collection. It's a collection of points with each point feature has properties, which are the aircraft state, including the hex ID. So let's just filter out anything that is not this United Airlines aircraft, just to cut down on the processing time, because this is a big file. It's like every aircraft on the West Coast for an hour or two or three. So A081CA. Let's just filter out every aircraft that isn't that. We have a bunch of aborts here. Like if there's no altitude info, just skip it. If there's no ground speed or whatever, skip it. So we'll just say, is it A08 C1A? 081CA. Okay, that should skip everything but that one aircraft. Let's see what it says. It should tell us red positions of one aircraft. While it's compiling and running, we really don't need airport ident. At least not right now. What other warnings do we have? We're gonna use timestamp eventually, but leave it in for now. Need that airport ident. Okay, red positions of one aircraft. That worked, and it didn't trigger. It didn't find any rejected takeoffs. That's fine. We're going to try to fix it. Yeah, fine. Okay. Do that. Call next. So what if we take off? What if we just take off the runway filter and make sure that it flags this flight? Okay. So did find it. That's good. Let's actually, now let's use the timestamp info. So if we put start time and end time in the URL. So right now I've got it so we can just click on this URL, it'll load up that flight, but it loads up like it'll show the entire day of history for that aircraft. So maybe let's get a little more specific. Yeah, see, it's just everything that aircraft has done. Let's make a rejection struct. So right now, detect rejected takeoff returns true or false. Let's make it return a little more info. How about we'll just call it like the start and end state. Start and end aircraft state associated with the rejection. Okay. Right, we're not calling close to runway yet. Let's comment it out so I don't spew warnings everywhere. So now we're going to return option rejection. So now we know. Actually, you know what? Let's just to make it real simple. Let's say that we have an end state or state. No. Called the reject state. State when we determine the rejection occurred. So now we return some rejection. Yeah, that's right. That's a GitHub Copilot suggestion. Oh, maybe it's not right. Yeah, okay. This is an AC state. Doesn't clone. The other case, so we're going to go back and fix that, but the other case is none. We do this. Yep, we can. Now in the URL, so we'll get a rejection can give us, I'm going to do that's not quite what we want, but we're just adding a little function that will print a URL or return a URL string that we can use to make debugging easy. Is it hex? Aircraft state? Oh, we don't keep the hex in the state. Okay, that's fine. Let's call it aircraft hex. Now when we create the rejection, don't have the hex here either. Yeah, that's right. Now when we call it, sometimes I call it IKO and sometimes hex. Okay, so now do if let sum rejection equals. So if that function returns a rejection, print the URL. Okay. Now, oh, that didn't quite work. Yeah, so we need a clone in here, right? Forgot, is there a... Oh, there's a clone. Macro. A few others. I don't know if we can do EQ since it's floats. Yeah. Okay. So now down here, can we just clone it? Yep. Okay. Okay, so now in the URL, let's specify a somewhat more specific time window. I think it's start time and end time. Start time, end time. We already do show trace with the date. Okay. A little date, little time arithmetic here. So we'll take the timestamp equals reject state, or self.reject state. Let's take 3 minutes off. How about 5? Oh, what's RHS? That's not. Is there a chrono duration? Okay. End time. So start time, subtract 5 minutes. End time, let's add 2 minutes. And then we're gonna, because we just, for the URL, we just want minutes and seconds. Or I mean hours and minutes. It's all UTC, so that works out. Okay, let's see if that works. So we just want to see, does it, so it found the right aircraft. I mean, it only had that, it was only looking at that one aircraft's data, but it did find the rejected takeoff. Let's make sure it's homing in on the right time window. Yeah, I think that's about right. 2232, 2239. It's on the ground at LAX. It's looking good. Yeah, hell yeah, that's it. That's the one. Okay, that's great. Now, since we got this one great little example that we can test with, let's make a few other changes here. So, detect rejected takeoff. Because it has a history over 1 or 2 or 3 hours, there could conceivably be multiples. Yeah, let's not worry about that for now. Okay. So now we want to do our runway filtering. Because that was what was breaking it before. We'll just run, oh, we'll just run it just to make sure. Right, we commented that out. Let's take a look at the runway data. Okay, so now we do want airport ident, because we're going to do a little test here where we're just going to print out the distance to LAX runways. Okay, let's try that. This will just give us an idea of, well, why was the runway distance filtering it out when it shouldn't have? Because that's definitely close to the runway. Oh, the other thing we can do is okay, so that's not right. It's the distance in meters. Well, okay, that plane did fly a lot, right? Okay. So let's Let's run it again. Let's get all the distances. Let's find the minimum distance to an LAX runway. That should be like a few hundred or 1,000 meters maybe. It's not very much. I mean, there are not very many entries here. Does that make sense? Process runways. Sorry, it's close to runway. So we call it for any on the ground position. Would have expected more, but okay, maybe it's not too bad. Let's just print the lat longs, just to be... Do not disturb, I said. Let's print the lat longs just to be... Just double check those. That's right, is it? It is. Aircraft position, runway position. And it's actually long lat. This is gonna be it. I feel it. It's gonna tell us some info. What? If the runway position is actually an integer, that would do it. Parse, one parse. Oh wait, runway position. Oh god. It's longitude and longitude. Why is that? I really don't know. I'm sure it's my runway. It's my dumbass CSV parsing. Lat. So maybe it's supposed to be that? Yeah, I think that might be it. I would have saved an hour if I'd spent like 10 more minutes writing that code. Okay, rejected. Freaking takeoff. Why didn't it print anything? That seems odd. But whatever. Okay. Since it sort of looks like it might work, let's take out our debug filters. So we'll do it for all airports, not just LAX. Let's just run it in that state and make sure it works. And then the other filter is on the ICAO-X, which is what? 808. Okay. Okay. I think we're gonna see. There might literally only be this one rejected takeoff in the entire data set. So maybe that's what we'll get. We know that it does find the one that's there. Oh. This could be pilots doing traffic pattern work. Let's take a look. So we didn't really put anything in there to stop those from showing up. Or if anyone just gets close to a runway. Yeah, see, I mean... So maybe... What is that distance? 10,000 meters might really be too much. That's North Island Naval Air Station. Let's just see what that is. So that's like... Yeah, it's way too far. We just try like 2,000 feet. Hopefully we'll still get the United Airlines. Doing a little webcam lag test. Looks okay. I mean, it's kind of interesting how a lot of the time it's just reading that GeoJSON. Okay. This is not the United Airlines. What is this? Is it the same damn jet? No. I don't know why this... I was talking with a pilot friend today about these this phenomenon of aircraft showing that they're on the ground even when they're definitely flying in the air. And so I learned that the equipment, there's a couple different ways they can determine on board that the transponder decides whether to say, yeah, I'm on the ground right now or I'm not. One is a squat switch. So if there's pressure on the tires, you're on the ground. Then the transponder says, yep, we're on the ground now. Otherwise, we're in the air. But some aircraft don't have that, so they just use airspeed. So if you're below like your stall speed or something, it'll say it's on the ground. But I'm guessing that's way above the stall speed, but it's saying 0 feet. And it's close enough, you know? This one I'm not positive how to filter out. Well, okay. Let's just check a couple others. I do have some ideas about how to maybe filter that out. So again, helicopter saying it's at 0 feet. Okay. Let's look at the next one. An auto gyro. It's reporting it's on the ground. It's by runway. And it's actually, okay, so this is one thing I was thinking of trying. So the altitude state can either be a number or it can be the string ground. And currently I'm collapsing those two things. If it's ground, I just set it to be 0. And I thought, well, maybe I should just look for ground. But that wouldn't have filtered this one out. But it might get a lot of them. So let's implement that. Here's our altitude parsing. Yeah. Oh, right. If it's a string, we assume it's ground. We set to 0. So just to be pretty bogus about it right now, let's try that. So the effect of this is that we're going to ignore anything where the altitude isn't reported as the string ground. I mean, the next thing we could try to use to filter this is the aircraft needs to be moving, has to be moving with a heading that is the same as the runway heading, or close enough. That would work. Okay, got a couple. Where is it? I can tell already this isn't the time of the ground stop, which I think was like 2230 Zulu or something. Okay, this one not showing an ADSB exchange for some reason. Okay, so we only found 3. This is our United Airlines jet. Okay. Got that one, proving it can detect a proper projected takeoff, and it got the auto gyro. Okay. Well, gyro is also pretty much on the runway heading, very close. So yeah, he goes 60, 62. He's accelerating, decelerating. Almost on the runway heading. So it'd be hard. It'd be a little tricky to filter that out. I mean, if the threshold on the heading delta was pretty small. But, I mean, we're already at just 3. So what's going on with this one? Oh. It's a Mexican 737. Where is it? Let's look at January 10th. I'm just making sure there isn't something weird like that. For some reason that URL isn't working. Okay, so now we see it. And the time was, well, let's look at, time was 0004 to 0011. It's not that one. It's not that one. Not that. That's interesting. So there must be, I mean, I think I did my daytime arithmetic correct. I was wondering what might happen if it crosses a day boundary, but this one doesn't do that. It's close. So here, let's look for the, let's see if we can print out the runway. So this is now going to return the runway. Rejection. Didn't include that. I guess we don't really need to put it in the rejection, but that's okay. Debug. So it's just this. So we got 3. The first one is the one we're trying to figure out, Mexican 737. The second one is that's the United Airlines jet that really was a rejected takeoff. Third one is the auto gyro that I'm going to give up on, trying to filter out for now. Okay, KSNA, San Diego. I think that's San Diego. Oh, John Wayne Airport. So we don't see that here on this day, which is weird. Did it ever? Huh. So looking on the website, we don't see that it goes to John Wayne Airport. But the history has it there. our data file. I could try to print out or save a GeoJSON version of its path, but I already know that this is not at the time we're interested in. So I know it's not rejected to the ground, or it's not related to the ground stop. Let's just see where it was when this happened. Oops. So just paste that lat long in. Should be on the John Wayne Airport runway. Is it? It's not actually on the runway when this happened. So I don't know why we can't see it in ADSB Exchange. On any date around the time. That's odd. But wow. What's the actual? So when we do the rejected takeoff, we print the actual. This is the first position that's a deceleration. So I'm going to say that over here by these hangars wasn't a rejected takeoff. Secondly, it doesn't look like there's room for a 737 there. So I'm going to say something else is going on. And I think at this point, I'm going to say that we have... I'm pretty convinced that there's not another rejected takeoff that happened during the ground stop or during the time period covered by this data. I think we did it. Yeah, out of almost 7,000 aircraft, millions of data points, I think. We found 3 candidates for rejected takeoffs. One was indeed a true rejected takeoff. The other 2, one of the 3 definitely was not. It was an auto gyro, just Mad Maxing it around. And the third one, it's a little bit mysterious, but the evidence suggests that it was not a rejected takeoff. So I think we're done with that. It's a nice little end point for this. I guess I'll decide whether I'm going to look for go-arounds. I think that might be interesting. So we're going to look for... Maybe next time we'll look for planes that were on final approach and had to go around because something went wrong, someone was on the runway. Another thing that might point to the increased distraction and workload of this ground stop affecting flights. All right, well, I did not expect to get this far tonight, actually. The last episode was so disappointing. We barely did anything after an hour plus. And I kind of thought today would be more of the same, but I think we finished this chapter, mini chapter. All right, until next time, thanks. Good night.